Главное, с того ютуба себя расслышат. Wait, initial. Pronto, obrigado. Раз, два, три. Раз, два, три. One, two, three, four. Audio test. Please, anyone who can hear me on the YouTube streaming, can you please send something to the Indeed channel on Slack? One, two, three, four. Ah, there is something. Okay. You should see streamed the gist that I've been sending in the email and the GraphQL channel. Can you see it properly on the YouTube? Very nice pixels. That's great. There's a bit of lag between the YouTube streaming and the reality, so I will be responding with some delay. Sorry for that. I'm glad you like the pixels. Okay, I'm going off the Slack now and we can start. Okay, I hope everybody is prepared and you have installed everything that was needed here and sent in the gist. If no, please do it right away. We are going to need these technologies in a few moments. And since we are starting, I would like to welcome you to the GraphQL hands-on. My name is Peter Čaněk, and Tomáš Horáček is going to help me on place. If you have any questions, please ping him, and he can help you. As for the organization goes, in first part, we are going to have a short presentation about the technologies we are going to use and play with today. Then we will jump straight into the implementation. There will be short break for dinner, approximately for 30 minutes, I would guess. I say it would be something around 6 o'clock, probably. We will see when it will arrive. Here in Smečky, we will have pizza, and I hope you will have something nice at other places too. And if you have any issues, please write into the Indeed channel. Katka will forward your questions and problems to me right here. So if everybody is ready, we can start. It looks good. Okay. So what is GraphQL? I will start with a really short introduction what the GraphQL is and what we should expect. And simple answer to that question is that GraphQL is alternative to REST. You can think of it as a API provider, one of the ways how to build APIs. So we are going to get some data from it. We are going to post some data to it, update, mutate, delete, you know it. And that's basically it in a nutshell. We have a really nice diagram here. Instead of Apollo client here on top, you can imagine basically anything. It can be relay, it can be application built with any other technology, mobile application, desktop application, doesn't matter. It talks to our GraphQL server. It can be in Apollo GraphQL or GraphQL Yoga, Prisma server. It doesn't matter. And GraphQL, it's completely up to us what we teach our GraphQL server to do. It can talk to some databases, Redis, MongoDB, whatever we want, or some external API to load some files from disk and serve them, or just generate some random data and send that. That's very useful for mocking and fast prototyping of applications. Today, we are going to use the method of loading data from the disk. That will be our first implementation of the GraphQL server. That will be the first step. Then we are going to extend it with a Prisma, use Prisma as a ORM layer, and let Prisma generate our database, mutations, and stuff like that. We are not going to care about that stuff. And in the end, we are going to end up with a GraphQL server that is able to get some data, store the data, and be persistent across time. I'm sorry for the blinking projection here in on place. I'm not sure why is that happening. Probably something is overheating my laptop maybe, so sorry for that. And let's go to the technologies. First of them is GraphQL Yoga. You can find it on GitHub as every other technology. GraphQL Yoga is basically a set of libraries with some predefined variables, configurations, and boilerplates for us to create GraphQL servers more easily. Because there's plenty of technologies you want to use. If you want to use subscriptions, they are pretty powerful. You can do that, but you need some library for that. You need to plug it in, or you need to maintain some connection, probably a WebSocket connection, and that can be not hard but tedious. And GraphQL Yoga is exactly for this. You just take the library, you put it in, fill it with type definitions and resolvers, and you have server with a lot of defaults. Just a moment, I'm going to rewire the projection. There are some technical difficulties with the projection here in Smečky. Tam je to ten, to není projektor, ne? Já jsem to chtěl jenom odtáhnout od těch datových zdrojů.
A možná i VGA je spolehlivější. Jestli chceš VGA.
To mám jenom 1024 rozlišení.
Ono to tam jde. Okay. Ale
Zkusíme takhle.
bych možná vypnul auto ten hledání. Okay.
Okay, sorry for the delay. I hope it will be okay right now. And back to the GraphQL Yoga. We are going to set it up as a first technology in our stack. Yeah. Apple tracing, that's pretty interesting stuff, pretty new if I'm not mistaken. Basically, with GraphQL Yoga, it is already implemented there. You can run your query and it will run the analytic version of the query. So you can see every single resolver and feel how long it took. So you can prepare your query, your mutation, send it, and then see, okay, everything is pretty smooth running. And this one part is taking long, so I should look into that and optimize it. We are going to play with that in just a few moments. Yeah, of course, GraphQL Yoga is extensible with middlewares and a lot of other stuff and plugins. So pretty cool starting point. Another technology already mentioned is the Prisma. You can think of it as they describe it as a ORM-like layer between your GraphQL server and your databases. We are going to provide a schema in GraphQL schema definition language. And out of the schema, Prisma is capable to generate the full database with the tables, with the transactions and stuff like that. And on the demo server we are going to use, we don't need to even care what type of database is there. The data will be stored. And yeah. What is really interesting on the Prisma, it generates the database and also the full GraphQL server. So we are going just to describe the types, what we are I'm sorry, but this is really bugging me. For those on YouTube, there is some problem with the projector and it's still on. And it's really blinking pretty hard. So let's have a 5 minutes break for technical issues and we are going to fix it. Sorry for that.
I'll try to turn off the auto setup. And yeah, also try.
To můžeme, ale budeme mít výrazně menší rozlišení. Došáhne? Plus minus. Vytáhni ještě to hledemíčko. Jo.
Co je nejlepší guru?
Dvou největší guru. Nic nesmí.
Jde to pořád vidět na YouTube?
Jo, já tady dám video, ne, tak to je komputer.
Jo.
Vidím tvoje škrasy.
Jo, komputer. A podle mě by mělo jít nastavit rozlišení.
Nejde mě to na nastavit ovladače. To už mám vyzkoušený, proto jsem chtěl jít přes HDMIčko a hodinu mi to tady běželo v pohodě. Okay, so let's continue. We will see if the projector will be running smoothly right now here in Smečky. Sorry for the technical difficulties and the delay. And back to the Prisma. So what we are going to do with the Prisma is pretty simple. We are going to describe our API once more. Let Prisma generate the full database and all the stuff around the database. Also on the servers, so we are not going to care about that. We are going to let the Prisma generate the CRUD API. We are going to play with that around, so we can see what was generated for us, what we can do with it. And then we are going to plug in Prisma bindings. And That's the final piece that will take the Prisma server and it will generate SDK out of it. So instead of querying the Prisma server with queries and describing everything we want, we can just do something like this. So context.db.mutation.create recipe and pass some arguments. So our Prisma server will basically behave like ORM and we have it done. So that's the last technology we are going to use. If we have time, we can look into some authentication and some more advanced stuff, but we will see in the evening what time we are left of it and how it will go. So that's our technologies and our application. We are going to keep it pretty simple. We want to build some simple GraphQL API with persistent data. That's our goal for tonight. It will be very simple book and author database. Like I said, really simple schema. The books will have only the ID, name, description, and author, link to the author, and author will have only the ID, name, and biography, nothing more. If we have more time and we want to make it more complex, we can add some reviews or extend the definitions a bit more. So that's the end of the presentation. If everything is clear, we can go to the coding. If everybody is ready with the technologies and no questions are asked, I will wait a few seconds for the guys on YouTube to have opportunity to respond to. Okay, so there are no questions, so we can go to the coding. In the gist I have sent days ago, there are no new links. If you want to see the presentation and you want to click through the technologies I just mentioned, it is here. And please go to the repository over here, clone it, and we are going to use it like a basic boilerplate. I will be uploading periodically the code we are going to develop here. So if you are stuck with something and your code will break in some real interesting way, you can just take a newest version from the Git and continue from that. So I will wait a moment for you to clone the repository. Please do not push anything to the master branch. Too late? What? No. That would be bad.
How would we do that? Are we contributors?
No, I didn't play with the permissions at all, so it shouldn't be possible, but I'm not sure. That's cool. So after that, you should end up with this structure. The presentation is the source code for the presentation you have just seen. So we are going to ignore that completely. And only interesting things are the package.json and index.js and test data. So I will wait a few minutes for everybody to be on track. And then we will continue. The link to the repository is in the gist that was sent in the free all email. Also, the link to the gist is in a GraphQL channel on Slack. It's one of the pinned items. It's the first one. So if you don't have it, you can get it there. Okay, who is not ready? Do you need some more time? Okay, we will give you 1 more minute. One more time for the guys new on a YouTube streaming. If you have any questions, please put them into the Indeed channel on Slack. Katka will forward them to me or Tomáš, so we can help you. Okay, so let's go. We are going to start from the index.js file. We are going to start with a very simple GraphQL server with the GraphQL Yoga. So I'm sorry, I had some. Not you. Oh, not you. This is my little helper here because I don't remember all the commands from head. We are going to import the GraphQL server from GraphQL Yoga. For the GraphQL server, we need two main things. One are the type definitions. Second are the reservoirs. The type definitions describe shape of our data, how they look, how they are connected between each other, and the resolvers gives us the opportunity to say, okay, I have this type and I want to give him this data. So the resolvers are the thing that are connecting our type definitions with the data we want to provide. So we need to first create the type definitions and then the resolvers. The type definitions will be created in a separate file. Let's call it typedefs.grapql. GraphQL is a typed language, and it has two root types that are the same for all the servers. One is optional, and that are the mutations. But the type query is the initial type that is used as a root query for your GraphQL server. So what we put here are the root queries that clients can consume. And then you can define any type you want and stuff like that. Should I make the letters bigger? Okay. So let's start with something very simple, and we are going to implement a simple query called info. And this query is going to return string, and this string is non-nullable. That's this exclamation mark. So most the exclamation mark is that this field, the query info, cannot return null value. Without it, we can return anything. With it, the null value will be omitted and error will be thrown. So this is the most basic way how we can write GraphQL schema, and we need some resolvers for it. Resolvers are map of objects that are going to map to our types, and we can say how every type is resolved in it. So we have the object. Inside we have the query that is corresponding to the query we have here. And inside the query we have the info query. So we need to write how to resolve this one. Each resolver is a function that is taking a lot of arguments. We are going to take a look into the documentation in a few moments, but right now we don't want to use any of them arguments, so I'm going to omit that. Use the arrow function from the ECMAScript 6 and return just a simple string. So we keep it simple. Also, one note, there is a prettier package configured in this project prettier is code formatter with some best practices in it. So if you want your code to look the same way as mine is looking, because as you have seen just a moment ago when I hit the save button, it was automatically formatted. You can use it with yarn prettier. It is configured here in package.json as a command. So these are our resolvers, one resolver. And that's everything we need for the GraphQL server we are going to use. So we are going to use the GraphQL Yoga as a starting point for our server. And I'm going to copy paste it from here. Yeah. The GraphQL server is taking object. First are the type definitions called type defs. This is taking the path to our type defs.graphql file. And second argument are the resolvers, which is the variable we have defined here on line 3. So this is the configuration of the server. Later on, when we are going to play with the GraphQL, with the Prisma and Prisma bindings, we are going to extend the context of the GraphQL, and that will be done here, but more on that later. Right now, we only need to start the server and play with it. I'm going to use this really nice message over here. The syntax is server.start, and the start function is taking callback function that will be called after the server has successfully started. So you can just pass a function there and print any message you want. In default, GraphQL Yoga is starting on localhost and port 4000. Think it's clear so far? If yes, let's see if I have written it properly. I've set it up a command to start the server, very basic one. You can see it here in scripts, server start. It is only taking nodemon and certs index.js. For the ones who don't know the nodemon package, it's a pretty simple package that is just taking all the files in your project, watching them for changes, and if any changes are seen, it will relaunch this command with a node environment. So if we make some changes into our index.js, nodemon is going to see them, kill the current process, and restart it once again. So the command to start it is yarn server start. And I have made some mistake. Probably in this one.
What's the error that you got? Because I got that nodemon is not recognized. Probably didn't know.
You have to see the yarn. Yeah.
Yeah, if you got the error that nodemon is not installed, run just yarn, this command. This will install all the packages that are specified in package.json and the yarn log file, and after that it should work. And it seems I have written wrongly the type depth path schema.
I think
you are missing the suffix, dot GraphQL suffix.
Yeah. Probably.
Yeah, because it is importing JS file. As
Yeah.
GraphQL definition.
So this should work now. Okay. Server ready at localhost 4000. So let's take a look. And we have a playground here. Let's erase this one. Okay, everybody got the playground on a localhost 4000.
Also, I had to restart my computer because of the bug, so don't worry about me. I'll just.
Okay, I will let Tomasz help people here. And do we have any issues on the streaming?
Maybe teacher, can you push the record?
Yes, of course. Let's do it. Yeah, the error I have made is in index.js on line 12. I was missing the .grapql suffix here. That was my error. If you got no schema defined, you are probably having the wrong path here or wrong file name here, the typedefs.grapql. In typedefs.grapql, you need to have the type query and inside that info string. And that's all. If it didn't help, please ping with more details. I'm going to send a new version of the code.
Because index and your definition is on the same level.
Yeah, but it takes root of the project.
Yeah, and I am running the nodemon command from root of the project. So it is specified from the place where you are running the command.
Maybe we can use path resolve and delay, but for now it's okay. Jo, určitě přesečko já zase.
The new version of the code was just pushed to the repository, so you can take a look and compare your local version and the version I have just sent, or just sync with it. I will go through the files once more slowly. The typedefs.grapql is are our type definitions with only the type query. Inside of it, only the info with type data type string, non-nullable. That's it. In the index.js, we are importing from the GraphQL Yoga package the GraphQL server, only that. We are defining the resolvers for the query and for the info query. That is only returning just the testing string. And then we are initializing new server out of the GraphQL server thing we got from the GraphQL Yoga. We are passing configuration object to it. That's this one with typedefs and resolvers. Resolvers is this object, and typedefs is the path to the typesdef.grapql file taken out from the root of the application. And then we are just going server.start, and we are passing callback function to the start method. That is a function that will be launched after the server has started. Everything good? Everything good on YouTube streaming too? Okay. So if we have this very simple server, and with the playground, we can play with it a bit. We have got this playground thingy. There are some tabs on the top, some prettify options, some history and stuff like that. On the left side, this is the place where we are going to put our queries or mutations. On the right side, this is the place we are getting the data, and the tracing will be hidden right now. So if I go to the completely blank slate, we just open up the object. We are getting the type ahead helper to see what we can do. We have the only the info query. We can run the prettify to have it nice, run the test button, and this is the output. Our server is not capable of any more interesting stuff, so this is basically everything we can do here. But we can go to the documentation. On the right side, there is this schema tab. You can see the list of your queries, mutations, subscriptions, and everything in here. It will get a bit more full in a moment. You can click on a info query that is here, and you can see it's only returning the string and some definition what is string. That is a scalar built into the GraphQL, and that's basically it. You can search. We are going to use the auto-built documentation a lot more in the near future. More interesting things are on the bottom. We open up the query variables or HTTP headers. You can attach variables or headers to your calls, because in the end, this what you write on the left side will be put into a GraphQL string that will be sent to the server with the HTTP headers and the query variables. So when we are going to run the mutations, we are going to put the variables over here. And if you remember, I was talking about the Apple tracing library on a start with when I was describing the GraphQL Yoga. This is the part when we can see how it is working. I will rerun the query, and now the tracing request was sent with the with our query, and we can see that the whole request took 8 milliseconds. The info part took 190 microseconds. I'm not sure what's this for. Micro. And sending the response was 15 milliseconds. So pretty cool tool to analyze your server. So can we continue? On the second run? Yeah. It will be because there are some pre-built cachings into the GraphQL server. The GraphQL Yoga is doing a lot of, not magic, but a lot of interesting stuff that is pretty handy. And in most servers, you would want it. And it is doing that for us for free, basically. It's really interesting to see the documentation, what they are building from what pieces and how to do it yourself. But that's out of scope for this hands-on. I think I can demonstrate what we are talking about right now. If I rerun the server, up the tracing pad. Yeah, right now the whole request took 42 milliseconds. If I run it for a second time, it took 7, 11, 5, 8, 7, 8. So there are some optimizations built into the GraphQL Yoga out of box. Yeah, you do. You would need to look into the GraphQL Yoga. You can play around with it a lot. There are some pre-built configurations, but you can change them. You can add your own or even remove some stuff probably. I didn't try that, but I believe you can do it. Or you can see how they are doing that, because they are just putting a lot of libraries into one place and connecting them together. And you can do it yourself via their way without the stuff you don't want. For a big project that has really specific needs, you can do that, and it could pay off definitely. Okay, so let's do something a bit more complex than just a plain old testing string. If you take a look into the source directory, there is the testdata.js. That are the testing data I have prepared for this hands-on. We have the book list. That's our 4 books objects. Each book has a ID, it has name and some description, and link to the author, the author's ID. We have 4 books, and then we have author list with basically the same ID, name, biography, and that's it. This is the one of the authors, second and third. And we are just then exporting it so we can import it and play around. So let's import it into our index.js. And now we want to write a new type for it. Let's start. Let's start with the author, because author doesn't have any link to anything. It's a standalone entity without any linking from its own. And first, we need to write a type definition for author. This is a new type. We have some ID of type ID that will be non-nullable. We have name, which is string. We can let that to be nullable. And the last field is the biography, which is also string. Depends if you want to use it or no. This will be our public API, and for public APIs, sometimes you want to provide the IDs to your users, and sometimes you don't want to. But if you want to provide them, you need to define them. You need to define every field you want to send throughout the API. Basically, in this file, we are describing the shape of our API. Yeah, definitely. And we are going to use the author's ID in a few minutes when we are going to describe the books, because the linking between the books and authors is done throughout the ID. This is, yeah, it will be shown in just a moment in a description. Basically, the GraphQL on its own has the built-in types ID, string, integer, or which is int, float, and that's it, if I'm not mistaken. It's just of these views, and then you can extend, you can build your own types. We are just doing that. You can build enumerables, so you can build some predefined options. You can build interfaces, unions, fragments, and a lot of crazy stuff. We are not going down that road on this hands-on, but we are going to create our own types.
Basically, you are limited by JSON, because the GraphQL uses JSON, so anything you can encode in JSON, you can encode in GraphQL.
Yep. I'm going to just repeat that for guys on streaming. Tomasz just mentioned that anything you can code in a JSON format, you can put here, because GraphQL is based on a JSON. So in the end, when the queries are transported on the network layer, on any other layer, it doesn't matter, it will be serialized into JSON format. Mm-hmm. The question was if the GraphQL is checking if the IDs are unique. GraphQL on its own doesn't do that. The Prisma can do it. So GraphQL basically doesn't care about the data you are providing or the ways how you want to provide the data. How you implement your resolvers is completely up to you. It only takes care of the shape of the data if the shape is correct. If you are not trying to put integer into the string and vice versa, it will yell at you the type definitions that you are doing something wrongly. But if the ID is really unique, that's completely up to you. So this is our type. If we don't have any questions on streaming, we can continue with the resolver. Yeah, and I forgot one more thing. Because I have just specified the author type, but I didn't put it into our root query. And this root query is the thing we can see here. Everything what is inside the root query will be here in the list of queries. And what isn't there, it will not be queryable from the root level. So we need to specify what type of query we want. And I say I want one author. So this is our type, author. This is describing the shape of the author, what is carrying with as a data. This is name of the query, so we can name it author query, and this can be info query. This is a bit nicer. Just do that. The author query will return just one single author, and the author will be in this shape. So this is our in our type definitions. Again, the author query in a resolvers map takes a function with a lot of arguments, but we are not going to use them right now. And let's just return the very first author we have in our author list. So basically a level up from the plain old static string. And that should be it. We don't need to have changed anything on a graph in these parts because the type definitions are specified dynamically here, the resolvers too. So let's test it. If I refresh my GraphQL playground and go to the schema, you can see I have the info query of type string and author query of type author. You can see on the left that our previous query we were running the info without the query keyword is underlined in red, and it is telling me that we cannot find field info on a type query. And if we take a look into the author query, we can see the specified author we had here. And here is the definition of the ID scalar, the scalar type ID, how it is defined in GraphQL. So let's fix this. Close the tracing because we don't need it right now. And as you can see, when I have updated the info query on the left, the data on the right updated. That's cool. Author query. Out of nothing, because author query is returning object, it's marked as a wrongly typed query. Because if we are returning object, we need to specify what fields do we want to consume. That's done again with the curly braces, and let's just get everything. Let's run the prettify, and let's run it. Excuse me? No, there is no shortcut. You need to specify it explicitly. The question was if there is shortcut to just say give me everything on this field, there is none. You always need to be very specific what you want, in what shape do you want it. And as you can see, this is the result. We have the author with ID author1 with his name and some biography. Sorry for the check. I was taking that for the database knih.cz. And to the shape of the query, if we take out the name and put it on top, as you can see on the right, we have the author query in that object, ID, name, biography. Let's run it once again, and now the name is on the first place. So we are defining the way how the data should look. That's one of the biggest selling points of GraphQL, because if you have something much more complex than this author query, you can just say, okay, I want these two fields and omit the rest. I don't care about the rest, and give them in this order. And you can play with the order on a client side. And the client, it can be anything. It can be mobile, desktop, or web application. It doesn't matter. Okay. Everybody good?
I'm on phones and I have some help too much.
Okay.
Again.
Yeah. Yeah, it's just completely without commas, the type definitions. It can look pretty strange, but I like it in the end. Yes?
The type def, why do you define author as nullable and the string with the bank?
It's completely up to me. I don't have any reason behind it. I can just put a exclamation mark here, and it will tell me that the author query always needs to return something. So let's play with that. And let's do something like this, because the author list has 3 items. So getting author list with index of 5 should return undefined. This was reloaded. Let's run it again. And now the data is null. And we have one error. Cannot return null for non-nullable field query.authorQuery. We have the location where it was found and in what query. So now the GraphQL server is sending me error that there was some mistyping with the data, and it cannot provide the data in the shape we want. If I change it back, we are going to get a pretty interesting error over here. Let's rerun it. Yeah, now it's working. Now we are just getting author query null with no information why it is null. So if we are going, if this would be some query that is taking parameters, let's say the ID of the author, we want to have the information. Okay. Is it there, or is there any other error? So yes. To the error scenario, yes. The error scenario starts with author query with the exclamation mark over here. Let's reload this one. Run it.
I'm sure I can. How do I manipulate the message? I don't want that message cannot return.
Oh, in middleware it is possible. You can create your own messages. If you throw JavaScript error here, I can check here if the value is what I want, and I can throw. Yeah. Let's. Okay. Yep. And as you can see, I have thrown this is error with double E on a start here, and the error message is now in this way. So if there will be some specific way, let's say authentication error, I can do this. And as the error will bubble throughout the JavaScript calls, it will be handled by the GraphQL server and sent to the client. Or with the middleware, you can change the shape of the native GraphQL errors. Yeah.
Yeah, I used middleware to pinpoint which fields are wrong in the GraphQL mutation. So there was like ID of the input that should be corrected, or where the error should appear. It's possible.
The thing is, I believe most of us will do a migration from REST API to GraphQL, and the client side is waiting for error status code, and I don't see it there.
Yeah.
Yeah, I think it's error code.
Yeah. Yeah, you can use. Yeah, I edit error codes to my server. It is not there out of the box, but it is possible to do it. It's not that hard.
I will just summarize the discussion that was here in Smečky. The discussions were about the error messages. If we can customize them or change the native error messages, these ones. If we can change this message to provide some ID or code or anything else, we can do that, but we need to implement our own middlewares for it. Mm-hmm.
Does it make sense to implement GraphQL database, the user and some relational database?
Yeah, why not?
Because if I already have a relational database, why would I need to use GraphQL?
GraphQL is not a database. It's a more of an API. It's alternative to REST, basically. So it's a middle point between your database and your user. If your client, any client you want, is talking directly to the database, you don't need either REST or GraphQL. But if you need some API, you can do a lot of variations. The REST is one of the major points right now, but the GraphQL is alternative for it.
For example, in Express, you can also make an API.
Express is a completely different thing here. Express is a Node.js application that allows us to run Node.js applications with a middleware. A lot of GraphQL servers are built on top of Express. So right now we are running Express server hidden down here in the GraphQL Yoga in the end. And yeah, you can use Express to build REST, or you can use it to build GraphQL. It doesn't matter. Okay. So let's expand this once more. Let's get a full list of the authors. Yes, sure. Yeah. There was a question, and for the guys on streaming, there was a question, and Tomasz is handling it right now. So we are going to continue to see how we can return all the authors we have in our application. And since we already have the type author specified, all we need to put in is a new query. I have named it author list query. And by specifying the braces, this type of braces around the author, I'm telling the GraphQL that this is the list. And here will be 2 exclamation marks. This one on the right side is an exclamation mark that specifies that the list alone cannot return null. So if nothing is returned, we will get something or error. And this here specifies that this exclamation mark, that the author cannot be null. So basically, this is the same as here. And the second exclamation mark is to the braces around.
So we are saying that we cannot have a null untyped list.
How can I have empty list?
It cannot be empty, and the list itself cannot be null.
No, it can be empty. It will be always list, and there will be no nulls in the list. Yeah.
Yeah, to repeat what Tomáš just said, I was a bit confused. Thank you, Tomáš. The list itself cannot be null. It can be empty, but the items in a list cannot be null.
Which is useful. Usually.
Why do I need to know that author cannot be null? How can GraphQL get the list, pushes to it and null value?
GraphQL can't. You can. You can make it by a mistake or some wrong data in your database, broken up migrations. Basically, putting inside the list of stuff some nulls or undefineds in JavaScript. It's pretty easy and it can break a lot of stuff. And having some specified errors instead of just exploding bullets is much better. Of course, you don't need to put the exclamation marks here. It's completely up to you. So, no more questions. We need to right now implement the resolver for this query. I will just move this here. And the way is very similar as with the rest of the queries. And instead of returning just one item, we are going to return the full array like this. Now, when I reload, again, we have one more query type here. It is returning list of authors, non-nullable and non-nullable. The author type is the same as in this type, in this query. So let's run it. Author list query, and we are going to get the ID, name, and biography. Run prettier, so it is nice. Run it. And now you can see we have the data object in it, author list query. In it is the array. This is the first item with a very long description. The second, George R.R. Martin. And the third author is David Weber, and with lack of loading data in my GraphQL playground. So these are all the data we have specified as data.js. This is our author list, author 1, author 2, author 3, and we are getting that. Yes?
Do I need to write the ID name and biography? Or is there any filter that tells me everything what is there?
No. The question is if we need to write all these ID name, biography, and stuff like that, or if there is some asterisk that will return everything. No, it isn't. You need to be explicit and write explicitly what you are looking for with every single query or mutation you are writing. And in the end, it really helps with some advanced magic of the GraphQLs. Because what you can do with statically typed query, you can take it, you can replace it with ID, store the query in database, and just send throughout the network the ID of this query with its specific shape. And the server itself will know, okay, this ID is this query. Let's run it around and use it.
It seems bad, but it is a feature that is from the beginning by design, because as the schema grows, it will add more and more fields. So your old mobile application would suck more and more data that will not display to the user. So each client exactly says what exact data they want. This is the feature. This is the main feature of the GraphQL, that it's very hard to replicate for REST API. With REST API, you will return all the data all the time. There are some versioning, but it's very hard to maintain.
But going back, you were saying, so the query itself has its own ID.
Good.
It could. What I was just describing a moment ago, it's a opt-in feature. You basically add packages on your clients and on your server. You do some build magic because it needs to be done during the build. With some libraries, you can do it in a runtime. I think Apollo Server 2 allows this feature on a runtime, but it's a opt-in feature. It's not out of the box in a GraphQL. Yeah. Okay. So if this is clear, I think we can add the books into our list and make some connections between them. If everybody is okay with that. Okay. Let's describe our book type. Again, our book is going to have an ID that will be non-nullable. It has some name. It has some description, if I'm not mistaken, how I named it. No, it has some description. Cool. Which is also string. And it has author. So this is the same as we had in a author type. Exactly the same. Only the biography is changed to description. Nothing interesting there. But this field, it allows us to bind one type to another one. Basically, we are saying that every book has some author, and it must have an author. So, and this is the type connections, the relations between our types, and the very powerful thing in GraphQL. So let's see how the resolver will be written for this one. Also, we need to write a new query for this. And then we can play around to see what we can do with it. So let's do the book query. Yeah, book. Thank you. Book query of type book, non-nullable. That's cool. Let's implement this one. Book query. And for now, return the first one we had over here with the author query. This is not all what we need to do because we didn't write anything to tell our GraphQL server how to resolve the author field, but we can try to test it if we can work without it. This was reloaded. I will reload this one. In the schema, we can see that there is the book query of type book. The author field is going to the author type, and if I click on it, I can see the type of the author. So the linking is here. And if this would be a much more complex structure, we could go throughout the fields and see what is there. So let's try it. Try to get ID, name, and description. Let's prettify it. Let's run it. And it's here. We have the book of ID book 1, the name Mali Prince, and description again in check. Sorry for that. If we add the author, just like here, it is again underlined in red color because the author is of type author and must have some selection of subfields. So we need to again specify what we want from the author type. And we want just a name. Everything we want. Let's run it. And here you can see that the author was returned and his name is null. But the author itself is here. So what we can do with it to implement the resolver that will make the linking between the author and the type correct. And
Before jumping into that,
Mhm.
So, is it possible to say there is good practice on the type definition to add all the properties of the object, and then on the query you only choose what you want?
Yeah, I will repeat the question. The question was if it is good practice inside the type definitions, so inside this file, to add everything that we know about the types, and then only in the queries specify exactly what we need. And answer is simple, yes. That's the point of GraphQL. Here you are describing your data, how the data looks, and you don't care about your clients, what your clients want. I, as a backend developer, here specifying my GraphQL server, don't care if there is some mobile client that will only take the name and nothing else, or if there is some rich desktop client that will always take everything and display everything to its user. It doesn't matter to me. I just provide the shape of the data and then provide the resolvers to get the way how the data should be fetched. Did that answer your question?
Yeah, I'm just thinking of the security.
If you have some fields that shouldn't be displayed at all, you don't put them here. That's simple.
May or may not, depending on your credentials.
Yeah, and for that exactly, you can add packages or your own implementation of authorization, and you can just say, let's say with the headers, you put your JWT token here, and in your resolvers, you can take it and see, okay, does this user have the permissions to see this specific field? And we are going to look into that, how to write resolvers for fields right now. I'm just going to fetch water. Thank you.
Maybe we can do it at the end of this session, the security authentication and access to different fields. But it's solved problem, and with GraphQL, it's much easier than with REST. You will see it.
I will just repeat what Tomasz just now said. If we have time at the end of the session, we can go through authentication and authorization, how to do it, for queries, for fields. And Tomasz mentioned that it's in the end, it is much easier to do it properly in a GraphQL than in a REST, because we know the issues with REST. You have everything for the endpoint, and if you want something for part of the endpoint, it can be pretty tricky. Okay, so yes.
From the book list query, you've got the list of all books with the author and probably with his name. Right?
Not yet. Right now,
Because I got
yeah.
only, how can I mention, author ID with the.
Yeah, that's what we are going to implement right now. That wasn't implemented yet. I've got from my query, I've got the ID name and description of the book, because that's implemented. That's these data. And about the author, I asked for the name, but the name is null. But if we take a look into the data, I was taking the book 1. That's this one, and that's pointing to the author 1. And that's this one, and I should probably pick some author I can pronounce. Sorry for that, but you probably know him and this book too. Yeah. So let's take a look how to make this link working. I will take a look into my previous implementation to see how I did it. Yeah. Okay. So what we were right now implementing in our resolvers was only for the query type that is defined here. That's the thing we have implemented for so far. But the same way, we can do it with a book. So this object ends here. I will add another part in our resolvers below the query called book. I will take a look into the author field. Again, it will take the function. Okay. And the author field is going to return, let's for simplicity return the first author we have in our list, or the second, so it is the wrong one. We are going to return for every single book, we are going to return the same author, so no linking here, but for now let's test it. And now you can see that the name was changed to the George R.R. Martin, which is the wrong one. This is not the author that is linked to the book. And what we have done here, we have added new resolver. This is the whole object. This is the second part. This is the first part of the resolver object. The second part was named book. S is our type book. And we have added a specific resolver for the outer field, for this one. We have just said return second item from the outer list array. That's what we have done, and that's the reason why the George R.R. Martin is going with us for the Mali Prince book.
That should be a very different book.
Yeah, Mali Prince written by George R.R. Martin. That could be pretty interesting. What we want to do, we want to return specific author based on a data that is provided by us, because when this is evaluating, when this is running this piece of code, we have already run the code to get the book. So we know the information about the book, we know the ID, we know the name, description, and its author ID that is inside our test data. And we need to access it in our resolver. And based on this information, we need to find this this part of the array. The resolver takes a lot of parameters. Now we are going to play around with them. First one is the object, arguments, context, and information. The object, the first argument is basically the parent object of this specific type that is right now evaluating the specific resolver. So for this book and author field, it is its parent, and parent of this author is the book. So basically in this object, thank you, console. If we just console log it out to see what is inside and run the query one more time, we can see that inside is a object with the ID book1, name Mali Prince, description, and author. So basically the first parameter is what we are evaluating right now. So we can get to the value of author, the author -1, via this piece of code. And if I rerun the query, you can see that this what is missing object is author 1. Is this clear? Nobody's throwing anything at me, so that's cool. So let's find the proper author. Excuse me? Yeah, sorry, I almost I forgot about that. The first one we have explained. The second one, args, is the arguments of the query we are running of the specific type. Because with the GraphQL queries, you can add arguments to it, IDs or pagination, anything you want, some filter parameters. And we are going to use that with the mutations just in a while. And it will be passed to the args. The context that is provided by the GraphQL server, you can put whatever you want in it. We are going to put the GraphQL instance with the GraphQL bindings to the context. And the info object, to be honest, I don't remember from head for what it is.
I think it is info about the query, how it is like nested, and you can like introspect.
Yeah, the meta information of the query. Yeah. We can take a look into it. Why not?
Will be very
It will be probably very big, very big.
But the context is very useful. It is like shared state for the request. So you can share, for example, authentication or the anything useful.
I will just repeat. The context is very useful because, I will repeat one to one, because it is you can share data in a context between different between the requests. So you can put authentication there, you can put connection to the database and some other stuff, and you can use it in other resolvers across your application. So let's take a look how the info object looks. Yeah, it's pretty big. If you want, you can go through them and see what was evaluated, how it was evaluated. You can do pretty cool magic with it, but it's out of scope of this hands-on, I would say.
It's more for libraries or...
Yeah, definitely for library stuff. Yes?
A while ago, you logged the object.author.
Yes.
And it automatically logged the ID of the author. You didn't need to put .id.
Because in a book type definition, I have just author, and this is containing the ID of the author, as we can see in our data.
So not the whole object.
No, it's only containing this.
Yeah, it is logging the data you put in the upper resolver. So what you put in the query resolver is what you get in the book resolver later. And now you have to process the ID into real author.
So to have it, excuse me?
Don't you need just one author? Now you're getting a list.
It was, you are right that the filter is returning list. I can use the pop, and there was the one alternative, bit smoother. Find.
Yeah.
And with the,
Find will find the first, which is
bit nicer than filter that pop.
let's hope this polyfill already.
Yeah, this should work. Okay. Let's test it this way. And now we can see we are returning the correct author. If I change this to return third item from the book query, we are getting completely different book with a proper author name. This was just a basic array magic in JavaScript.
When are the types actually applied? Because I got into this weird intermediate state where I'm not defining a resolver for the author on the book. And at the same time, I'm defining that the author on the book should be required with the bank. But I can do a query where I say, I want this author and I want to select the name from it, which is nullable field. So I will get the name as null. But if I ask for ID and name, I will get an error because then the ID doesn't have any. But we don't have any author at that point because we didn't resolve him. So I get the query, it finishes correctly, but the name is null.
I'm not sure if I got the question correctly.
On one side, you have required requirement for
Yeah.
an author, you have the ID.
Mhm.
On this other side, you say, I will expand whatever I got in here this way.
Yeah.
And I only ask for the name.
Mhm.
And so the result was a book with an author whose name is null.
So basically, it was
Well, if you remove this resolver and
yeah. If I go to this state,
yeah, and then in the query you just ask this,
yeah, I'm getting the null.
null.
Yeah.
But you should get an error because you didn't populate the author because you don't have any data.
I would get the
Ask
the
for
error.
ID as well, and it will tell you that the ID is sent.
Yep.
There are no data.
There are no data. But GraphQL on its own is taking the object that is trying to that is it got for the in this case with these kind of resolvers. What we have here, we are running the book query and we are just returning the object. So we are returning exactly this. This is the object we are returning, and on outer field, this is a string. And what is GraphQL trying to do? It is trying to go to the outer.id or outer.name or outer.description, and outer.name and outer.id and description or biography, it's undefined because string.something is undefined. That's the thing in the JavaScript.
But to your type system, you're saying, I want an outer, but you get a string. And you have no properties on that string defined. So you get into place where you should be getting an instance of outer in like object-oriented speaking, but you got null, but you don't throw any exception. Then you select name on that null and you return null, and that's correct.
Yeah, this is because string is an object.
Yeah.
It's not an outer. That's why we have the type system.
Yeah, the types apply only to specific query. So until you require something that is not present in the object, then it is okay. But yeah, it is kind of like partially JavaScript and partially design of GraphQL.
Okay.
Maybe in different languages it will be different, but usually in dynamic languages this is what you get. And this is like real edge case and you can solve it, but this is like very naive implementation, and yeah, we are not dealing with this.
Okay, it was just a very obvious middle step between not having a resolver and asking for a type, so I was expecting, I'm asking for something to be not null.
Yeah.
Now it's null, I get null.
Yeah. Yes, string is not null and it is object, so it is still valid in the logic.
You can ask for properties of a string and
but if we say we have a type system,
no, it is very nice object.
it's I'm not sure how it will look in a strongly typed language. I don't know. Think of anything, but in JavaScript you can get into these kind of things, and it will explode on a over here.
You need to ask for something that's non-nullable in the query, and then you will get an
some scholar.
Yeah, and you will get a null in the meantime. Because if I go with just the name, I'm getting that something is not right here.
Instead, you should be getting an error that says you didn't specify any resolver for this type, so do it.
That's the thing. We didn't explicitly specified resolver, but GraphQL has built-in resolvers for every field that you are describing. And basically, what it is doing, it's taking the type definitions, and for the objects you are passing, it's trying to find the same properties with the same name in that object. So there is a built-in resolver behind what we are doing right now. That's the thing we are using here in the outer. If I go to the outer thing, if you can see, we have no resolvers to see, to tell GraphQL how to get to the data of the ID, name, biography on an outer object. If we go into the outer query, we are just getting object foo, and what is GraphQL doing? It is taking this object and trying to find the ID, name, biography on it. And the same thing applies on when we are doing that throughout the book.
But then there it's easy. We just say, this is a string, so you just check, I get a string. And then you
String
have
is
a
an object.
single type system where you can specify, I want an outer, but instead you get a null string with null property, then you get null. Now go on, it's just very weird.
Yeah, it can get weird. Welcome to JavaScript, basically. Okay. So maybe I can just implement what is GraphQL doing for us, because I didn't specify any resolver for the author field, and GraphQL is doing basically this. Give me a second. And if we go to the new tab, get author query, get ID, name, and biography here, you can see it works. And if I replace this with string, it's like this. We have the name Peter, and for every author query we are going to run, there will be name Peter. And this, what I have just written here, this way, that's auto-generated for us in the background by the GraphQL. And this is basically what the GraphQL was trying to do. It was trying to do the object.name on a string when we were running this query. It is trying to get to the name. It is trying to get to the ID. And string.name is undefined, and string.id is also undefined, but the ID cannot be null. So it exploded on the ID and not on the name, if that helps a bit.
No, I totally get the reasons why it happened.
Yeah, cool.
It's just weird that we get this promise of a type safety over something that doesn't have types. And so then we get this weird error. Well, 5 types. You have 5 types.
Yeah, JavaScript is funny.
Oh, it works. It's just a little bit.
Okay, so the author was removed. I think I can just commit the code for you and upload it. Okay, if you want to see the code, it is there. And I think that's everything we want to do with the GraphQL Yoga. Now we can take a look into the Prisma. So we have seen how to implement some queries, how to implement some types with their specific resolvers. We have seen how to write some types, how to describe our shape of our application, and we are able to return stuff.
Maybe
Yes?
What about returning books by author? Because then we can like nest query infinitely, like author query, author query.
With the argument, you mean?
Maybe because we don't have to do it, it will be done all by resolvers, and maybe it will be interesting. I don't know how much time do we have.
We are in a halfway through. We are behind before the Prisma and GraphQL bindings. So
because it will be just author
Yeah.
Booklist.filter.
Yeah, it wouldn't be that hard. Okay, so we can try to see. The idea was to see all the books by a author.
Yeah, to have like two-way connection between author and book. So you get all books by author, and you know the author of the book.
Okay, so we want to have the author. We want to have the books field, and this will be array of books. And let's do it this way. And now we need to implement resolver for this one, basically the same way as we are doing for the author, but vice versa. So let's do it. Author object over here, comma over here. It in real world it can, but in this testing scenario, no. It's one book has one author. It was actually quite funny because when I was picking the books, I went through my favorites list on Databáze knih, and most of the books from David Weber that is here was a lot of his books, and a lot of my favorites were written with some other guys. And I was like, okay, not this one, not this one, not this one. I don't want to implement this.
Can we use the arcs for the filter data?
Yes, that's exactly what arcs are for. Because you get every argument into the arcs object, arcs argument here, and you can use it to filter your data, to paginate your data, to do whatever you want. Oh, sorry. And pizza arrived. Okay. How hungry are you? Put your hands up. Not so hungry, hungry, really hungry. Okay, it seems we can wait another 30 minutes. So we will implement the...
No, it will be like 5 minutes.
Yeah, let's implement the thing we have just started. And then we can have like 20, 30 minutes break to have some dinner. And then we will return and continue with the Prisma. So we will have this nice break in middle.
Yeah, Mark asked if you can show us the filtering.
Yes, I can try. I will implement this one and then we can go to the filtering for just a moment. Okay, so we are trying to get all the books by this author. And we have named the field we want to write resolver for as a books. Again, it is taking function and we want to have the object here. We don't need args, context info. I will pass it everywhere. And for that, we need the book list and we need to filter it. You don't need to. Only parameter we need here is the object. The rest is optional. You can do it like this. I'm just putting them there to have like for us to be sure that there are more and we can work with them. The info object will not be used at this hands-on. The rest will be. And we want to return item outro. It is. Yeah. Basically, I'm just going through the book list, so through this array, and searching for every book that was created by author, by current author I'm working on right now. So I'm going item author equals object author, because currently I'm working with some author and I don't want author, I want ID. Yeah.
No, you are in the author and you resolve books, and the object is author.
When I am working in this scope, the object is instance of author. And which author was returned depends on a query that was run. And if I go with the author query, this one, it will be the first author in a list.
So on author, the object is of author.
One more time, please.
On the author is over, the object is of author, but in the book, the object is of author because it's how we find it on the tab.
Yeah.
No. Even on the book, it is instance of book, but book has .author field. So.
And author has field books.
.id.
Okay, this is running. We want to have the author query. Let's reload it and see if the author query has the books. It doesn't. Yep. Now we can see in a type author, we have the books, list of books with the types we want. So let's try to use it. Books. And we want name and not description.
And author ID.
Just the name for now. Prettify, run it. I will erase the biography so it is empty array because I've forgot the return statement. Yeah.
Maybe use it on author list. Maybe more author list query. You can change it here.
Yeah, and this is the result. I'm asking for list of all authors in our application, their names, field books, and name of the books they have written. And I'm getting Exupéry with Mali Prince, George R. Martin with Tanec Draki, and David Weber and his 2 books that are in our database. And if I go from books to, I'm going to do that in the previous one. If I go in the books to the author, get his name, and again to the books, and go to its name, and it works. I can go with infinite loop. There were pretty interesting talk about exactly this problem because you can pretty easily make infinite loops of data in your GraphQL application. And the talk was on GraphQL Europe. There was proposed way how to stop this, and I have already seen few libraries that are trying to implement this. So you don't have infinite nesting because you can crash servers and everything with that. But if for some reason you need a list of all authors, their books, and if the books have more authors, you want to list them too, you can do it, just like this one.
So suck on that, REST API.
This one? What we have written here, we have added the author resolver, same way as we have added book. In that, we are resolving only the books field. The rest of the fields are the same way as previously, and we are just getting the book list, filtering it, and checking if current item author is equal to the current object we are working on, the current author and its ID, and just returning the array of the books.
Maybe if you rename the object to author and item to book, it will be more obvious.
You can. If this makes more sense, we can definitely do that for sure. Here, the first parameter would be the book.
So it's not a good practice to use nested queries.
It depends. Sometimes you need it.
It's useful, but you have to somehow restrict it for end users somehow. Like
Okay.
to yeah. There are ways how to restrict it.
For the guys on streaming, there was a question if it is good practice to use nested queries, the same way as we have written here. It depends. It's really useful, so you can use it. To some extent, it's really useful. And since only the programmers are the guys who are writing this, as long as you don't have any dynamic queries in your application, you are good to go, basically. You can just optimize the stuff that needs to be optimized. Because if we run the tracing here for time, we can see how long everything took. Since we are reading it from a disk, it's pretty quick. But with the Prisma, it will take a bit longer. You mean this one? Only thing we have added here is the books field with array of book and non-nullable both the book and array. I can send the code one more time if you want. Okay, I think we can call it a short break for, I don't know, 30 minutes is okay, or 20 minutes? Okay, so let's meet here at 18:05. Bon appetit, everybody. Thank you for attention, and let's meet here in 20 minutes. We are going to Prisma, and we are going to use the to add the. Už mě vypla? Sdílím. Cool. Jsem slyšet? Hello, guys. Let's return back to our nice GraphQL API. Please, someone who is listening on a streaming, ping in Indeed channel if you can hear me and see the code properly. If nothing broke, we will wait a moment. One, two, three, four, 1, 2, 3, 4. Can you hear me? There is no response. Mark is typing. Ah, great. Okay, everybody ready? So there was one request to see how the arguments can be passed and used. So let's enhance our author query of argument so we can pick author we want. First of all, if I remember correctly, we need to specify it here. Let's name it how we should name it. Author ID, it will be of type ID. And am I writing it correctly, the arguments?
I hope so.
I hope so too. Okay, let's try it and see if it works.
Can we write query instead of object as the first argument of author query?
You mean just rename the variable or query?
I think in query case it will be
Root.
empty object. Yeah, root.
This is the in this case it will be a root, and it's basically empty.
You can define it in the server.
Yeah.
I think. It
yeah.
can be used similarly to context, but it's something different. Root is just for query. But
Basically, we can do this in this case because in most of cases when you are specifying either queries, query fields or mutation fields, you are not going to use the first argument most of the times. You are going to use it a lot when you are specifying resolvers for specific types. That's what we have done here with author and book. So I'm just going to put underscore here and second argument args. Let's start naming queries. What do you think? Author list query, book query, author list query, author query. Okay, I'm going to remove all of these. We have put it to author query. This what I've done here is naming of the query. The body of the query is the same as previously. The name is test query, and I need to put either query, mutation, or subscription before, so the server knows the type of the query. And to pass the to arguments, sorry, it should be over here. I should probably refresh, so I have typed ahead properly. And I have named it author ID. Author ID 5. You don't like me. Why do you like me?
Double quotes.
It needs double. Yeah, it's JSON. Ah, sorry. So double quotes for it because it's JSON and I'm used to single quotes Yeah. So this is the usage of the argument. Let's test it. This is Sparta author ID 5. What we have done here. First, in type definitions, we have taken our query and added arguments here. They are added in a simple braces. You need to name them, all of them, and you need to provide the type of the specific argument you want to pass. Then I am in a resolver. I have just taken the args and console logged out them. That's everything. And in our query, I have named the query and added again the simple braces, the author ID and value 5. If we take a look into the console, we can see it's over here. Let's try to use it.
I think you have to use find. Find by ID.
I'm going with the keys of the array. So values 0, 1, 2. Author index. That's true. It's int or integer? I don't remember. We will see. It will yell at me. Author index. We probably don't need this. Let's refresh this one. This is not yelling. Excuse me?
You have to rename it. Wouldn't it be okay to leave the name author ID as this?
I didn't have to, but I think for clarity, it is better because I'm going to use this value as an index for the array for searching. So the values would be 0, 1, 2, the possible values. If it would be author ID, the expected value would be author -1, 2, 3. So that's only for clarity. And since I specified the integer value, it requires me to go without the braces. No, author query dot something.
Yeah, just use 2.
True. Yeah, that's better. I should probably put some validations over here so the values go only as expected, but this is very simple argument we can pass here. Let's put it here into the query variables. If you are using the HTTP protocol to pass your queries around, this will be serialized as a string and sent to the server. And next to the string, you can send object of any data you want. And that's specified in here. The GraphQL playground is putting these two like variables together and sending it to the server. But server expects that complex objects would be put on a side, because this is basically a hard-coded value. This would be hard-coded on my front-end application code. And if I want to make it dynamic, I need to do it somehow. So I need to extend the test query to accept some variables. The variables are starting with a $sign, and this will be author index variable. It will be of type int. Now it is telling me that author index variable is not used. I will define it here in query variables. And put value for, let's say, 0 here. Sorry. I'm so used to go with Control S after every few lines, so I'm trying to save the HTML document. And to use the variable, it's like this. So this is the specification of the value. This will be the value in the real world application would be changed by some variable in your application, because this in a React or JavaScript application, this would be plain old object, nothing more. And this is, again, static query that has some dynamic value that will be added when the query is sent. You can see when I run the query, the author changed. If I go with 2, it's again David Weber. And that's very simple variables and passing. What is important here, if we want to use these variables, we need to define them next to the name of the query. This name is specified by me. On client-side application, it doesn't have to know anything about the server. You can put or whatever you want here with its type, in this case query, name it with the $sign on start, put it some type. Every variable needs to be typed, and then just use it anywhere you want. Is that okay? Yep. You can specify if the variables are required or no with this. And if you are passing the variables around in this way, you need to specify the same way here.
Basically, you should never concatenate string with the query, because then you may it may lead to something like query injection or like SQL injection. You should put the variables out and then provide it as a JSON. It is the safe way, the easiest way.
Yes, in real world application, this is the easiest. And creating this, because this will be serialized as a string, manipulating this string directly is pretty bad practice. You can do it for some specific use cases, but for most of the thing you need to do with GraphQL, you don't need to manipulate this string that will be created once. One more time, please. You mean like putting variable that is of some type? Mm-hmm. So you mean like renaming the, let's say, putting this over here. On build time, it is okay.
You can introspect GraphQL in all GraphQL servers, because you can create GraphQL query that will introspect what is possible, the whole schema of the database. This is what if you click on the schema tab, it will send GraphQL query into the database. And what you can do in your toolchain, you can have a script that will download this schema, and your toolchain then will check all the queries in your application. And it is possible. It is how it is done on most projects.
My question was only if Yoga can do it for me.
What you can do, introspection is out of box there. What you can do, you can write tests for these cases. You can write tests that will go through your code, find every single query there, and try to introspect it if it is valid or not. And then the test either passes or not passes, and you can see it on a build time or test time.
Yeah, and usually you don't need it, because queries are compiled. Usually you quote them in the, how is it called, the backtick string literal, and it is processed by Babel. So you write it as a string this text string, but it will be processed by Babel into something different.
It's processed by Babel, but it's not
Yeah,
checked against.
yes, it is. It is validated against schema.
It can be.
Yeah, it can be.
The question was just to repeat for guys on streaming. The question is if we can validate the queries before the production time, and yes, we can. We can do it with a Babel. We can do it ourselves. We can find every query in our application and validate it against the server at a build time or testing time. It depends on us, and there are already tools that handle exactly this scenario. And as you can see, when I reloaded the playground, after I have changed the author index to author index 2222, it's underlined as this is not valid argument for this this query. Okay, I think that's all for now, and we should go to the Prisma. We are kind of starting running out of time. We have only half of hour again. So let's go to the Prisma. Let's start our Prisma server. Why do you don't like me? Okay. So for that, I'm going to stop our developed server that we have developed right now. I'm going to send the code there. If there are some significant changes, yeah, they are. Okay, code is there. And now we want to start our new Prisma server. The Prisma will generate a lot of stuff for us. And the initial command, if I am not mistaken, sorry for the mess. It should be here. Yeah. The initial command we need is Prisma init and name how we want to call our service. What this command will do, it will create a new folder, put some stuff into it. We are going to set it up against Prisma server, demo servers. They are free, free of charge and nothing hidden there. So that's pretty cool. The Prisma servers are going to take care of the database, its migrations and stuff like that. And we are only going to provide the type definitions. So let's call it books ORM. That's the command. If I run it, I will be asked few questions after some time. Okay, now I am asked where do I want to put my new Prisma server, or to which database it will be connect. You can use existing database, you can create new database using Docker if you want, but we are going to use the demo server. I hope everybody has a Prisma account because you are going to need it right now. I'm already logged into the Prisma. If you are not logged in right now, you would be prompted in a browser window. You just log in there and that's basically it. In this step, you just pick the server with the lowest latency. Choose a name. I'm good with that. Yeah, develop server. And that's it. The next steps, open folder books RM, deploy with Prisma deploy. I'm going to go, let's do it here. If we take a look here, we have the new folder. There is the data model and prisma.yml. And we are going to look into that just in a moment. Everybody got this command and to the state where I am, the Prisma init books ORM. Some problems? Hands up, please. In that case, npm, Yeah, it was in the, I don't remember the command from head. If you have the link to the gist, it's here. Prisma click tool. Slack GraphQL channel, first pinned item. And there is the install command, npm install gprisma, and the Prisma init hello world. What is here is basically what we are doing right now with Prisma init books ORM. And in here we want Prisma deploy. I'm inside the books ORM folder. And we can see some changes has been made on some user type. It took some time and it's alive. Great. Let's copy the link. The link will be different for each of us. So you need to look for this link. I'm going to close some tabs here. We don't need this one. We don't need this one. This is our old playground and this is our new playground. What happened right now? Prisma took the Prisma YAML file over here. There is the endpoint at which your server will be alive. There is the source of your data. That's datamodel.graphql. And that's this file. You can see that this file is basically the same as we have been written here in typedefs.graphql. There is the user type. It has some ID. It's unique. Don't care about that. And it has some name. There are no query types or mutation types in Prisma data model. And that's it. So if we take a look into the server that was generated and go to the schema, I'm on my link that I have found inside the prisma.yml. I'll open it here. We don't need this data. Yeah, that's cool. If I open up the schema, you can see there is a lot of stuff. There are some users. There is one user. There are user connections. There is node. There are a lot of mutations. Or there are some subscriptions even. And if we take a look into the user query, we can see that there is a type user that is implementing node via the interface behavior. And it has some ID and name. And it is taking some arguments which are called user where unique input, and that's taking ID. So there is a lot of stuff generated for us. We are going to play around that in just a bit. But let's first update this data model to reflect our application. We are going to leave the user type here, but we are going to create author book. And basically we are going to use the same logic as we have here. So both of them have ID. Author has name, which is of type string. And in the end, I can just copy paste most of the stuff here. So this is basically copy pasted exactly the same what we have here, except for this books behavior. I didn't put that there. I can, but I don't want to. I'm going to leave it here so it doesn't break up. So far, so good. Seems so.
Should we specify ID as unique?
That's exactly what I'm going to talk about right now. The unique is, I just blank out how it is called.
Decorator.
It's decorator. Thank you. I think there are only two predefined decorators in GraphQL alone. This decorator, the unique, is defined in Prisma. And basically it tells Prisma to, if there is no specified ID, when creating new item, put new ID there with a completely unique value. So we can use this to generate new unique IDs. This is behavior of GraphQL, not GraphQL, but Prisma. We don't want the user type, so we are left with author and book. And that's our data model. There is no query type that is required for ordinary GraphQL servers, because this is not a one-to-one GraphQL definition. This is only a document written in schema definition language, and Prisma uses it on its own way, which is with 98% similar to the regular GraphQL server, but the difference is the query type is not needed because it will be generated by Prisma. Prisma is going to take this document and generate a proper GraphQL specification out of it. We are going to take a look into that in just a few moments. And let's run it again. If I run Prisma deploy right now, it will take the new file. It can see the lot of changes that were done here, that the user type was deleted, author was created with a lot of stuff. You can see that there is even some stuff that I didn't ask for, created field, updated it, and created it. These are the hidden fields. I can go to their values if I want. I can see them. And let's reload this one. Go to the schema. And we have the books. We have the authors, book, author, books connection, author connection. Okay, that's pretty cool. Let's try to run it. Let's get one book. Not one book. Let's get books. It will be a bit simpler with name and description. Let's prettify this, run it, and nothing. Because the Prisma database that was just created a few minutes ago doesn't have any data, so we need to create the data for it. So let's do that. Mutation. Let's call it create author. Let's use create author mutation here. This one requires some data. Let's look at it. Mutation create author. It takes argument called data and of type author create input with exclamation mark here. If I take a look into this create input type, I can see it requires name and biography. Okay. Let's put it into the query variables right away. So there is the data of some type. Let's create variable called new author with a dollar sign on start of type, which I will copy paste from here. Author create input because this is the required type over here. This to the side so you can see it. We are going to use the variable over here. And now it requires from me to specify which fields I want to return. Every mutation requires us to specify which fields of the object we are going to get we want to see, because mutations returns data too. So you are going to change the data and get some new data out of it. And now we need to specify this new author variable. A new author variable is of type author create input, which we have here, and that's an object with a name and biography. So I'm going to put an object here. with value test author. And these are our variables. No, because now we are working with the question was if I'm not missing ID. Now we are working with a Prisma, and the create author mutation was created for us. And if if we are not going to pass it ID, it will generate it. That's the meaning of this. Also, it specifies that the it must be unique on a database layer. Let's run this query. Sorry, mutation. It takes some time because now we are talking on a network on some free demo server, which is pretty slow. We can see that create author returned some ID, pretty long one. The test author and biography is pretty cool. Okay, let's erase this query.
Why the piece of code you had there before didn't work?
Oh, which one?
Like curate the books and the name with description of the books.
I don't know what you mean.
Just type Ctrl and Y.
You mean this one? This did work, but returned empty array because we have no books in our. Yeah, because we have created author, not a book. So I just erased it and list authors, and give us everything. Prettify, run, and we get it. If we want to create second testing author, we just do this. Create a new one. And it is there. These data are stored in a database. Which one, we don't care. And we can use them anytime we want. Everything good? Of course. I will make it bigger a bit. This could be better. Do you want to describe some specific part?
Maybe expand it. Maybe you forgot the exclamation mark or something.
If you if you make mistake in this part, the proper part should be highlighted with a red underline. It should look like this. This is probably the error you had. Okay, I will let Tomasz help. And in the meantime, we are going to use the same pattern to create a book. So we have at least some data in our database. So on a new, I'm going to repeat what I have just done with the outro. So, oh, sorry. New book. Create book would be of type book create input, which I will put here with the exclamation mark. Oh, sorry. create book, prettify. Book, and I want to get ID, name, the books have connection to authors, and that can be pretty interesting here in Prisma. Why are not helping me? Oh, I'm in HTTP headers. Okay, if we take a look into the book create input over here, we can see that author is of type author create one input, which is a bit more complicated because you can choose create or connect. Basically, what Prisma allows us here, it created a bit complex structure when linking the book and author. And now here in variables, we can either decide if we want to connect to some existing author or we want to create new one. If I type this, you can see I can choose. Let's do connect. The connect thing wants for me only the ID and ID of some existing item in our database. So I'm going to choose the second author we have created and copy paste its data over here. So the variables looks like this. This is the whole object. And for the author, we are choosing the connect way that is taking object. And this object is taking ID with some values in it. If I run it and expand it a bit, we can see we have the book with awesome book description, and that's it. Let's take a look over here at a query list books. Go with books, just the name, description, author on it. Please prettify yourself. No, thank you. That wasn't what I wanted. Like this. And we want name of the author. And now, if since I have two queries on the left side, I can pick which one I want to run. I want to list books. And we have the awesome book, it's awesome, and author second one. And the second one is the second author we wanted. So this is a bit complex structure, how to use Prisma, but it enables you to connect to any entity here. And what it enables you, again, it's to create a new entity. Let's see it. I will erase all the connect thingy here. Go with create. And let's see how the create looks like. The connect was taking author where unique input that was only taking ID. The create takes author create input, and we have already seen that here. In create author, this is the author create, how it's called, author create input. It takes name and biography. Okay. Create, it takes object. Let's name in third. Exactly. You are connecting to existing item in your database. Test. So this is the create. The object is a bit more complex because I'm passing two values. Let's run it. We can see the book was created. And if I list all the books, we can see there's the second one with a new author. And if I list the authors, we can see the first one, second one, and the last is the third one with the name third and biography test, which was created here in variables. You can use this to create a lot of stuff in one request. If you want it or don't want it, that depends on the requirements of the application, but it is there, and writing all of these inputs and mutations by hand can be a tedious work. So pretty cool, this one. Everybody got it successfully? Okay. So we have the GraphQL server with books, with authors, with a lot of persistent data in them, like 6 elements or how many? And we can play with them. What we are going to do now, in last 12 minutes plus everything we want to give on top, is connect our Prisma database, Prisma ORM, to our already existing server. This one we've been writing here previously, and replace these resolvers with GraphQL Prisma bindings so we can call the database. That's our goal. For that, we are going to need some stuff. And now I'm going to need my test sheet because this is really hard to remember from head. I'm going to commit this data model GraphQL and Prisma.yaml. Just be sure that when you, if you are going to sync with the code, you would need to replace this endpoint with something of your own. You are going to use the code I'm sending to the GitHub. It's really important here, what we have just done. This is everything we needed to write to get all this functionality we've been playing on this playground. That's pretty important because the less code you write, the less errors you can make. So, and now we are going to need GraphQL config.yaml. I'm going to copy paste it to the project and then explains what it does. The name is GraphQL config.yaml. In it, you need to have the projects, two projects, app and Prisma. App, the schema path should point into your application schema. So for us, that's the /type dev struct GraphQL. And endpoints default localhost 4000. That's good. And for the Prisma, we want to have the schema path. So I will just put search/generated/prisma.graphql and extensions. Extension would be pointing to books ORM to this file, to prisma.yaml. orm prisma.yaml. This file is a universal configuration file for all GraphQL tools. When you are going to dive deeper into the GraphQL world, you will see tons packages, and this is the place when you are where you are going to configure there. We are going to need is this path, because right now we are going to run the command that will take our existing Prisma server and download the file that is used for this server. I will just commit this single file. I will just check if I need anything more. This is okay. I'm sorry for looking into another project, but this is really hard to format because you do it only once. And command, yeah, that's the command, and that's it. This is the file. So the file is now on GitHub, so you can take a look into it, copy paste it if you want, and adapt it if you have any other names in here. Again, the meaning of the paths, the schema path should point to the typedefs.grapql we have already done. That's the first thing we have done today. The endpoints default localhost 4000, good for us. And in Prisma, you need to have the schema path that is pointing to the .searcher /generated /prisma.grapql. It will be generated. This is like target for the command that we are going to run in just a moment, and it will put it here. And extensions, what should be loaded. So this extension Prisma must look into the prisma.yaml file, which is over here. And this file is pointing us to the server and pointing us to the SDL definition we have written here. Okay? Yes.
The last line, there should be books, a book.
Thank you. Okay. So the command we are going to need is, yeah, for some reason it's a bit lagging, is this one. I'm going to paste it into the console here. The command is GraphQL space get schema space -p space Prisma. GraphQL.
I think we have to install GraphQL CLI.
Yes.
Globally.
That's true. You need to install the GraphQL CLI. I think it should be here. No.
It's GraphQL-CLI. So npm e.
Yes. npm install.g GraphQL CLI. This is the command. Just a moment, I will leave this for everybody to have installed it. Or we can just run it with npx, but it's okay. The command is GraphQL space get schema space -p Prisma. Get schema is the GraphQL package is not connected directly to the Prisma. It can do much more than this. The get schema is one of the commands it can do, and the -p Prisma specifies that it should be one of the Prisma subroutines for getting schema from somewhere. So let's run it. And I don't have it installed. Ha!
You have localized error messages. Is it Windows? Or?
It's Linux. Okay, I just use it npx because why not? And now we have a new file here in a folder generated, the prisma.grapql. This one is big. Basically, this is the description of the whole GraphQL server we've been exploring in the playground. You can find the type query we've been missing in a data model.grapql. It is here. There are the subscriptions, there should be somewhere the mutations over here, and all of the types we've been exploring, they are here. It's not that big, but it's like 10 more types and it will get really, really big. So now we have the file and we need to extend our server of it. We have this server and we are passing only the type defs and the resolvers to it. Now we want to extend the context, so the context knows of the GraphQL of the Prisma server behind it. For that, we are going to require Prisma out of Prisma binding, like this, out of our document. From package Prisma binding get Prisma, and I'm going to copy paste this and explain it in a bit. So this is the import on top of the file without the comment, of course. And here into the new GraphQL server object, we need to pass context. And context is taking function which should return configuration object. And it's taking some request. So inside this function, which is specified here, we are going to spread the request that was previously passed. And then we are going to extend the context with a DB, which will be object initialized out of the Prisma we have required from top. And the Prisma is going to take two arguments. The first one are the type defs, and mine are, yeah, this should work. It should work. I'm not sure if I should put the source here.
Maybe books ORM, maybe. I think it's book.
Yeah.
No, sorry.
Yeah, Sarasa, because I am looking for this file inside the generated folder, the Prisma GraphQL. So it should be like Sarasa, like this. And the endpoint, this is the live endpoint of your server. And you can get that out of the prisma.yaml. That is in our books ORM folder. So I'm going to take this and put it here. I've put completely different thing here. Prisma GraphQL. GraphQL config. You don't need to be here. Okay. So this is the thing we need to do. We need to import Prisma out of the Prisma binding package. Prisma binding package should be already installed. Let me check. No, it's not. So let's install it. We can add it to global scope. That doesn't matter. Theoretically, you can add Prisma binding as your development dependency because everything that Prisma binding will do. No, it will run. Yeah, it's runtime thing. So we need to use it. So just yarn add Prisma binding. Wait for it to complete. Yes, it is in index.js on top of the file. So this line on top of the file, like this. And the Prisma binding is the package we have just installed. And this is the stuff we need to add to the GraphQL server configuration on bottom of the index.js file inside the certs folder. Okay, let's try to run it. Server ready. So I didn't make any typo. Do you want me to send this code? Okay. Yes. It's in the repository and you can copy paste from there. So I will just added Prisma binding, stage all, commit, push. It is there. So you can see what was done here. Just to repeat, we have imported the package and in a context or context field of the configuration object that is passed to the GraphQL server, we are passing function, which is taking another configuration object, which is just spreading the previous arguments and extending it with a DB, which is out of Prisma, and that is taking type defs and endpoint. Type defs should point to this file, to the prisma.graphql, which we are generated just a few moments ago, and it should get the endpoint, which you can get from the prisma.yaml, which is over here. All good? Okay. So our server is running. If I go to the alt playground, refresh everything, it should be the same alt. It should still work. The schema is exactly the same because we didn't change anything except that we have added context, which can do pretty cool stuff. So let's close the files we don't need because all the YAML files are needed right now. The data model.graphql, the definition of the Prisma. We need the index and we need the resolvers for this stuff. Let's go with the author list query. We are going to change this one. The root object we don't need, the arguments we don't need, but we need the context. Context.db. And in our GraphQL server, the authors are just authors. So it should be like this. Let me check. And it needs the info object. So the author list query was changed to return context.db.authors, and that is passing only the empty object and the info. Good point. Info is taken from here. Thank you. Let's test it. Server is reloaded. If we go here, if we reload it to take a new definitions, open it up here, and we have changed it author list query. We want to have name and biography. Prettify, run. Not a function. Thank you. So I've missed something. Yeah.
query?
I'm missing the query. Just a second, I will test it. Yeah. What I was missing is context.db, then specify what you want, type what you want, and then the type you want. So I was missing the query here. And as you can see, we have the test author, the second one, and the third. And these are the authors we have created over here in our GraphQL server that was generated in Prisma. And that's it. If we want to extend the rest, the book list query, it will be basically the same. The author query would need to be extended by the arguments to pass the proper ID, because the author query, if we take a look into our server, not this one, but this one, the author query requires input, some of them, so we would need to extend it. But basically, this is the point of Prisma, because instead of writing some complex resolvers, we can just use this everywhere, and it works as our ORM. We are a bit over time. If you want, we can play with it for, let's say, 15 minutes, or we can stop here. You can play around with it for yourself. You can look into the Prisma documentation. You can look into the Prisma binding documentation. Basically, the rest of the queries would be very similar to what we have just written here in outer list query. The mutation would be much interesting, because you need to pass the correct inputs and stuff like that. It depends on you. If you want to stay here, we can do it, let's say, until 1930, or we can call it a day and done. This is the query. Ciao, ciao. This is just a query code test with outer list query and getting name and biography out of it. So, who is interested and wants to stay here for upcoming 20 minutes? Please, hands up. 1, 2, 3, 4, 5, 6. 6 people. Okay. Is there someone on a stream who wants to stay here? 4 people. Okay. If you want to stay here, please ping us. Otherwise, we are going to dismantle all the technical stuff we need for streaming and continue only in Smečky. I'm going to prepare last. Okay, cool. Okay, in that case, thank you everyone for attention. I hope you like it and learn something new, and have fun with GraphQL. And for the rest of us who is going to stay here, are you interested in mutations, or do we want to replace all of these with GraphQL or with Prisma, or in what we are interested? Okay. I thought they are the same, but I have some error here, so we can resolve it. I was just trying to write a book list query over here, and for some reason it didn't work. Let me check here. Mutation recipe ingredients. It should work. Recipes, book list query, context DB query books. Ciao. Recipe created. Recipe ingredient. Okay, to be sure, I don't know why this query is not working. What I was trying to show you is that I just implemented really quickly the book list query, trying to get a list of the books and list of the authors associated with them. Ciao. But for some reason, yeah, I need to probably this one. Yeah, I completely forgot that we have custom implemented resolver for the book that is trying to do it with the old JSON data we have here, and that was not working with the with the Prisma. But as you can see here, we have the book list query. We are getting the books with their authors with their names. Ciao. And we can implement one of the single queries with the arguments. So we can see what is needed done to get, let's say, one author with args. Do I have it here? No. I have just rewritten the author query to use the context.db.query.author with empty object and info. It should yell at me, and it will most probably. Let's put it here. Single author, and we want author query. Let's go with just a name. Previously, the author query required the author index with type int. There are some lost keys and stuff like that. And I have... Můžete prosím zavřít ty dveře? Previously, what was here was the author query with the author index int that was from the start of the project. We don't want that now, so I have removed it. And now the author query is yelling at me that Let's reload this one too. Yeah, now it's okay. But if I run it, it will yell at me. If I run single author, context is not defined. Yeah. Yeah, I'm starting to be tired, so I'm making more typos than I should. Sorry for that. Let's rerun the single author. And now it's yelling at me that the field author argument where of type author where unique input is required but not provided. So it's asking me for some input and I didn't provide it. Let's try to provide it. Argument where. And let's get list of authors with their IDs because I'm going to need the ID now. Test. Yeah. I know. Okay, this is the list IDs I wanted. Now I need to tell our server that this query is taking some input. And since the underlying inputs we want to use are exactly the same as the Prisma inputs, I need to mimic their structure. I can name the arguments in my own way, but it depends on a use case. Right now, I'm going to copy paste a lot of stuff from the GraphQL that was generated. And it is asking me for author where unique input. And I'm going to just go here, find it, take it with me, put it here. I'm really lazy. Here with exclamation mark. Now, author query is taking the where argument with exactly the same type as in the underlying Prisma server. And I can hopefully use it. We'll pass the arguments over here. So the author query takes exactly the same arguments as we are getting, and it should pass them on. I will reload the server. I will reload this one. Now the Pocky value expected something that wasn't.
You have to wrap it in object.
Yeah, true. ID like this and sorry. And let's get second one. Let's move this to the side. So this is the argument passing. It's tedious sometimes, but on the other hand, Prisma is generating a lot of where inputs and other inputs you can pass there, and not every single one of them you will need. You will need to filter only on some queries. There will be some queries you don't need to pass from your Prisma GraphQL. We all know it. We have databases with 150 tables in them, but we are providing only like 30 or 50 endpoints. So that's the point in this. So you are going to write some of the code manually, but it can be worth it. Okay, so let's try mutation. What do you say? That will be the last thing today. I hope I can do it. I should. If I'm not mistaken, I've already done it here. I did. Good. That is going to save my life. Let's see here. Yeah, we need to create the root mutation type. Type mutation. What we are going to create, new outro, for example. Create outro of type outro. But this requires to create input the arguments, and yeah. Let's take a look into the Prisma, how it does it. Let's find a mutation create outro. It's taking the data attribute of outro create input, specified here with name and biography. That's it. And it returns ID name biography. So we are going to take the outro create input from here. Paste it here. Add argument data with outro create input here. And it should be for the definition all. Yes, that's all. Now we need to implement the resolver for it. I will erase these old resolvers because we don't need them. Book list, book query will be in the end the same as the outer query. So let's skip it for now. Create the mutation. We've called it create outer. It's mutation or mutate. Mutation dot, and the mutation is called create outer. We will pass it's 2 arguments or 1, just the args. So this is the mutation we need. Create outro again, context.db, the mutation instead of a query, name of the mutation we want to use. We have got that here. Pass the arguments there, and that should be it. Reload this one and try to see if we have the mutation. Mutation is here. Create outro. Create outro is going to require some data, and we want to have the name and name biography. And input is data, and I guess we can probably pass it throughout the query. So type outer create input. That's the same stuff we've been doing previously. And here it should be like this. This one. Oh, do it just like this. So we have created the variable called input with the object of name and biography for our new author. We are using the mutation create author, passing the data, and to that we are passing the input variable, which is of type author create input. And we want to get the ID, name, and biography back. Let's run it. And we have this is it. Sorry. It was created. The arguments were correctly passed into our mutations, and if we want to list them, we have now 4. Thank you. Okay. Yeah, sure. I can commit the code. So the code is committed and almost uploaded. Cool. And I would say that's it for today. Thank you very much for attention. Do you have any last questions for it, for this hands-on?
So when I want to alter database schema, I just change GraphQL schema.
Yes.
Is only way how to change.
One of the ways. You are not changing specifically the GraphQL schema. You are changing the thing you have written here for the data model.graphql. This is not specifically the GraphQL schema. It's written in same language, so it looks almost the same. That's the point of it. And yes, if in this way, how to use Prisma, this is the only way how to mutate the database. But what you can do, you can specify that you don't want to use pre-built database from Prisma, but you want to provide your own. And in that case, you are managing the mutations on your own. You can do the forward, backward mutations as you want, as you like. That's one of the ways. As I see it, the Prisma library right now, I can see it as a really good tool for fast prototyping and pet projects, because with this you can create new API with persistent data in minutes. In the end, it's possible. In some middle complexity. For the real projects, I know of companies that are using Prisma in production, big companies. You can see it on their website. How to use it, if there will be issues or no, I don't know. From what I have used right now, I think it's better ORM than Sequelize, for instance, because Sequelize in Node.js is pretty bad ORM. But if it is really worth it to use it on some really big production project with a lot of custom things, I don't know. That's for us to test and see. But for small, for pet things, for demonstrations, for playing around, pretty good. And for big projects, I can see it, but we need to test it, basically. More questions? Do we have something on a Slack? I could probably launch it. Okay, guys, thank you for attention. Hope you learned something new and you enjoyed the time we've been together here. And have fun coding GraphQL servers.